we can just set that for everything.
Okay. So yesterday, what we talked about? We talked about conjugate rule. That was if you had radicals and roots. We talked about how to add polynomials together, how to subtract polynomials. That's how you distribute the negative sign. We talked about what degree is. We'll talk about those today. We'll add them in. We talked about the order, descending order, whatnot. But the big thing we left off on yesterday was Pascal's triangle. And the goal today was to go through Pascal's triangle until you really know it. And then on the homework today, there's, I think, 1 or 2 problems I would like you to use it on. So you can actually display that you actually know how to do it. Now, I believe we started a problem yesterday and we didn't get finished with it. I need to know what that problem was. Like what the parenthesis was, what the power was.
Something to that.
3x plus 6 to the 5th? Okay. And I don't know how far we got. I think maybe we just wrote it down. I don't even know what we did. But this uses Pascal's triangle. Okay. The triangle itself is the system we have that helps us solve, not solve, but simplify a polynomial expression. Something where you have powers. That's usually what this triangle is used for. So this is what the triangle looks like. And we should have had this written down from yesterday. But if you're not here, you want to write this little chart down. Now this chart isn't something like crazy, like how I'm making up the numbers. It's made from ones or is on the outsides, and the middle numbers are made from the 2 above that make the little wedge piece above it. So like 2 and 1 add to make 3. That makes 3. These make 2. The next row, there'll be ones on the outside, then you have 4, you have 6, you have 4, you have 1 on the outside. And then same thing, I think this is the last row we finished with yesterday, which is the row we need. And then if we went another row, I think this is the 5th row. I don't think we went further than this, but I'll write this down. Okay, there's your rows. Now what these numbers are, these are technically the leading coefficients, like for your answer. In the very end, it actually tells you how many numbers you have in your answer. That's basically what it's saying. So if your parenthesis there had a degree 0 on it, so it had like a power of 0, or it had a degree 1 on the parenthesis. Ours is 5, so we got to go down 5 rungs on the list. Degree 4, and this is the one we were using yesterday. This is degree 5. This is the list that we need. Then I don't think we even wrote this one down, but we have degree 6 and go further than that. The goal today was to finish this problem up so you could see it. I didn't want to pick something crazy, but then also to know how can we go online and figure out if that's right or wrong. Because obviously, I don't want to FOIL this whole thing out. Something to the 5th power means that you have 5 of the parentheses like this. I don't want to do that. I don't want to FOIL those out. To FOIL like 5 parentheses, 3x plus 6, 3x plus 6, you have to do the first 2. Then that they'll have 4 items written across. Those 4 items get distributed to the next one, so that'll be 8. 8 times 2 is 16, and then you'll have these 16 items times 2 in here, which will be 32 items across the board. I don't want to do that. It takes too long. I could get lost somewhere in between. I could forget terms. I could forget powers. There's too much room for error. So we have this little power rule. It makes this problem so much easier if you just know the power rule. So the power rule is this. You have to find which rung you're on the triangle. So I'm obviously on the 5th rung because it's the power of 5 for that parenthesis. So these are the numbers you need to write down if you haven't already. So you're going to write the 1, 5, 10, 10, 5, and 1, and write them out and space them out in front of you. So I'm going to write these down. So 1, 5, 10, 10, 5, and 1. So I just spread them out. It doesn't matter the spacing. I just spread out the numbers. And then behind each of those numbers, the 1, the 5, the 10, the 10, the 5, and the 1, behind each of those, you're going to put the 2 items in the parenthesis in their own little parentheses. So the 2 items that are in there is a 3x and a 6. If any of them are negative, fine, leave the negative sign on them. That's fine. But you're going to write each of those items behind each of these numbers. So this will have a 3x and a 6. Notice I'm just putting each one in a parenthesis by itself. The 5 will have the same thing, and so on and so forth. So I'll let you have a little bit of time. If you haven't written this problem down, you want to do that right now. we're not done yet. We're just, this setup. So I use the chart, I write down each of the terms that are in the parentheses next to each of those numbers. Now this is the part yesterday that once you see it and you see the process, it works every time no matter what the powers are. So what you do is you write down the problem where you go through and you put the powers on each of the items, and what I mean by this is that these things will each get a power. One will be the biggest power, one will be the smallest power for this problem. And what will happen is one will go down and one will build up in power. And as you do that, you'll see how the powers work. That'll affect the final answer. So this is the easiest way to do it. So what's the biggest power in my parentheses? 5. So I'm just going to pick one of these. It actually doesn't matter which one you pick. I'm going to pick the 3x. I'm going to put the power of 5 on it. So I always just do the first one. The second number, you put the smallest power that you can have without going negative. So I put a 0. That's just how it always works. Biggest power, that's on the parentheses, the smallest power. Then you count down for the 3x's. Since you pick this one as the 5, the powers are going to go down. So the 3x is going to turn into a 4 next, then a 3, then a 2, then a 1, and then a 0. The powers count down. On the 6, they started at 0, right? That one's going to count up in power. So it's going to start with 0, it's going to go 1, 2, 3, 4, and 5. And that should count up to the biggest power that you have on the parentheses. Right there, what you have written is basically the final answer. All we have to do is simplify it. So you just have to multiply and get what my answer should be in the very, very, very end. Okay? So, let's actually do the math here. This is the part where how far did we get? Did we actually write that all down yesterday? That's as far we got. Okay, perfect. Let's actually finish this out. So, 3 to the 5th power. 3 to the 5th, 243. Okay, 243, that's x to the 5th, because I'm putting a power 5 in here, power 5, on each of those, so 3 to the 5th, x to the 5th. The 1 is just out front, and the 6, what's 6 to the 0? A 1. Because anything to the 0 power is always a 1. Alright, next, so there's the front, and we'll multiply those here in a second. So 1 times 243 times 1, okay? Alright, so next, we're going to take the 3 to the 4th power, which should be 81. This is 81, that's 3 to the 4th, and then x to the 4th. We're going to take that times 5, and we're going to take it times 6 to the 1st power, which is 6. So we'll have to do that here in a minute, so it's nice to be our calculators. We'll go to the next part now. Hopefully everyone's kind of seeing where my numbers are coming from here. Next we have 10. 3 to the 3rd power is 27, x to the 3rd. 6 squared is a 36. So there's that one. We're going to the next part here. We have 10. 3x squared is going to be 9x squared. And then 6 to the 3rd, was that 216? Getting kind of big numbers now. Yikes. Then you have 5. We have a 3x to the 1st. 6 to the 4th. That's 216 times 6, that's a 6, carry a 3, that's a 9, and is that 1296? Okay. Alright, and then the last one here, we're doing 1, 3x to the 0 is a 1, and 6 to the 5th, taking that times 5, or times 6 again, that's a 6, carry a 3, 54, 57, carry a 5, 17, carry a 1, 7, 76, something like that. Okay, alright. Now, we're gonna go across, we're gonna multiply all those individual terms together, and that'll be my final answer. And what this is gonna give me, it's gonna give me the final answer. If I were to FOIL all 5 of those parentheses out, it will give me the final answer in descending order, which is awesome. So, 1 times 243 times 1 is 243, x to the 5th, and that's the biggest power, so we know that this is a degree 5 polynomial. So if we were to actually graph this thing, potentially across the x-axis 5 times, potentially. The next term here, let's see, taking it times 3, 2,430, is that right? Okay, x to the fourth. Next one, oh man, that's kind of a big number. Somebody want to just,
9,720.
yeah, that one's a little out of my range, I can't do that in my head. Next, okay, we can do this. It's a 4, carry a 5, 14, carry a 1, 19,440. X squared. Geez. Can somebody do that one?
That was the same thing.
Yeah.
19,
Well,
440.
Same thing?
Yeah.
Seriously? Alright, and then 7, 7, 7, 6. There's certain things I can multiply that. So many things. Okay, that should be your answer. Now, to double check if this is correct, because obviously you're just taking my word like this, how you do it. We're gonna learn how to type this into a program that we use online, and I have it on my website. So if you have a Chromebook, or at least one of your group members has a Chromebook, take it out right now. Let's do this. Take it your Chromebook.
Maybe Sam.
All right. Shameless plug, go to my website, mrward.org, or hsmath.org, or ghbmath.com, I don't care which one you use.
Sure.
Okay. And really, if one of you has it, you're good. We're just going to learn how to do this. So this is a nice way to check your answers in case you're not sure. Like, I don't even know if that's the right answer. This is a great place to go. So if you're on my website, hopefully the internet's working. We'll check this here. Okay, go to the little drop down at the top, go to PreCalc. Drop down at the top, go to PreCalc. And then if you scroll down, you're going to see a bunch of links I've provided you on my website. So I'm waiting for somebody to look up there. So there's a bunch of links there that I've provided that are kind of useful. I want you to go to the Wolfram Alpha link. The Wolfram Alpha link. Okay. All right, now I'm going to get rid of Pascal's triangle here. Okay, so if you're on Wolfram Alpha, it basically looks like a big search engine, correct? That's what it looks like. It's an encyclopedia. It's not really a search engine. It's not pulling stuff from the internet. It's actually just going to spit out information. You can use it for anything. You can use it for research papers. You can use it for anything. It just gives you information, true information, like verified stuff, not Wikipedia. Okay. What I want you to do in that search engine, I want you to type in parentheses the 3x plus 6. I don't know if you even need spaces, just 3x plus 6, close parentheses. You're going to do the little shift 6 key. It's a little caret. Shift 6. There's a little caret key. And then you're going to type in the 5. So it should look like this. The thing is, like, I don't even know if you need to even hit enter. It's probably already calculating it, but most part just hit enter so you can see this. So once you hit enter on that, so this is what you're going to type in again. This is the shift 6 key. You didn't know. Shift number 6. That's the button you're going to hit, right? Once you type it, you can scroll down, you can see the graph of what it looks like, you can see the information about it, you can see what it's used for. It's like overkill. But at one point, they'll actually have it in descending order. They'll actually have the entire thing written out, which is the thing that we have on the board. Now 243x to the 5th, 2,430x to the 4th. I want you to verify that it's true, that it's correct. So again, hopefully you're using Wolfram Alpha and it's actually working. Is it showing up there in the search? Is it correct?
Yeah.
Okay.
You did it wrong.
Oh, yeah, don't tell me that. I feel really bad. All right. Just the reason why I bring this up, it's nice to see that you know how to do this, right? That you can trust this thing that I'm giving you, but also you can go online yourself when you're at home, because obviously you're going to do some of this probably at home at some point, and know that, like, hey, am I even right? This can verify it. Like, yeah, you're doing it right. In fact, that website, if you had a membership to it, I think you can just sign up with an email. I think it's free. But there's next to that problem, there is even like one of those options that tells you, it shows you like, it says, show me how to do this problem. Like, show me the work. Like, there's a little button you can click. And it'll actually show like this. And it'll show you how to do it. Or it'll show you how to foil it if you want to really do that. It's kind of cool. But that's like if you had a membership and stuff. And you don't need to do it membership, don't do one. I personally, I use this website as like my go-to calculator. So if like I'm at home and I don't have like a scientific calculator, this is what I use. I know you can type stuff in Google, Google can also do it, but this is awesome because it gives you nice graphs, you can manipulate the graph, you can move it around and stuff, it will actually work. But also, it can do a lot more other things. It can tell you stuff that you might need to know in the future, which is kind of cool. Okay, questions, comments about this? Like the process. Okay, so like Meg, I know it's like your first day seeing that. Did that somewhat make sense to you? Okay. Is anyone else struggling with the concept of how I set it up? Because we can do another one where we just set it up. We don't have to go through all the work. But does anyone need to see how I set it up in the first place? Now the problem I'm going to assign you today, I didn't assign you a power of 7 or a power of 5. I assigned you one that was a power of 3. Power of 3. That's what I assigned today. Because I thought, like, if you can do it for a power of 3 problem, you can do it for pretty much any problem. Okay, and it will keep the numbers relatively small. But that's what I picked. Does everyone feel more comfortable with Wolfram Alpha? It's just a really nice website. They have an app in the App Store that you can also download on like an Android or iPhone. I think it's $2 or something like that. I bought it years ago, like when it was $1. It goes on sale. But you can just use the web. You can just go on Safari and just use it. So you don't need to download the app. So just keep that in mind. All right, but it's kind of helpful. All right, last thing, I want to do one more problem, one more. And there's a problem in the book, and it looks something like this. This was Y, I think, 5Y. 3? Or that was a 3 and 8. I think it was a 3. Okay. Anyway, there's a problem that looked like that. How you actually do this problem. They're trying to mess with you on all the parentheses and brackets and things. It's a FOIL problem. We know we're foiling. Like the overall math here in the middle is we're multiplying, right? We know that. What I would do before I start is deal with the weird thing that they're doing here with the parentheses. What they'd like you to do is distribute this negative sign through this parenthesis. And once you do that, get rid of the parentheses. So it's like this, 3x minus y minus 4. I don't know why, but the book starts you off with this type of problem. That's what you have to do. On this side, there's no reason to have the parentheses. They're just trying to mess with you. So really, you can just get rid of it. 5y, because these are being added. It doesn't matter about the parentheses at all. So 9x plus, or minus 3. There. It didn't make a difference. Now that we have this, now you can FOIL it together. Or distribute, however you want to say it. So we're doing a product rule, right? So we're going to be multiplying. My rule is you just take the first item times everything in the back. Oh my gosh. You write them all down. Then you take the second item times everything in the back. You take the third item. Again, it's pretty straightforward. How many items should I have written across the board in total? 9. Because you have 3 in the first, you have 3 in the second parenthesis. 3 times 3 should be 9. There should be 9 items written across. If I'm color coding here, 3x times 5y is 15xy. 3x times 9x is 27x squared. 3x times negative 3 is negative 9x. So there's the first 3 items. That's 3x times everything in the back. Same thing, going with the negative y times everything back here. Color coding. Negative y times 5y is negative 5y squared. Negative y times 9x is negative 9xy. And negative y times negative 3 is positive 3y. There's that. And the last item, that's the negative 4 times everything in the back. So here we go. Now it's getting sloppy, but negative 4 times that is negative 20y. Negative 4 times that is negative 36, 36x, sorry, not y, 36x. And then negative 4 times negative 3 is positive 12. All right. Should we be able to simplify in the end? Yeah, there's a few things I can add. Not very many, but there's a few things. Like there's y's, there's a couple xy's in there I can simplify together, that type of thing. In this type of problem, I don't really care about descending order. Like that one I did care. I did care that x to the 5th was first, and but there's 2 different variables. It doesn't matter the order, as long as you combine like terms correctly. So I'm looking at terms like the xy's here. is gonna make 6xy's, because the 15 minus 9. The x squared, there's only one of them. The 9x and the 36x is negative 45x's. Y squared, there's only one of them. Minus 5y squared. Let's see, the y's, do I have any of those? What is that? Negative 17y's and a 12. It doesn't matter the order. Now, the degree of this thing, what's the degree?
2.
2. It's 2. There's actually 2 reasons why it's 2. This is 2. This is degree 2. It has 2 variables with powers of 1. So those add to make 2. That's a 2. It's 2. That's the biggest power. A lot of the problems will ask you for a degree. Just be careful of that. Read the instructions. A lot of problems say find the degree. It's very subtle in the beginning. You might forget. Like you're doing a bunch of problems. Like you need to flip back the page. And like, oh my god, I was supposed to be finding a degree for all of them. Yeah. So there's just a few that'll ask you. If it wants a descending order, just put it in that. If it's more than one variable, don't worry about it. I don't really care about it. Questions, comments about the concepts. And again, the best part is you could type that in Wolfram Alpha. It would also do it. It would also show you the answers. I like to see that every once in a while in case you're really stuck and you're like, I have no idea if this is right. Because you know some of the problems I give you are even, some are odds. So the odds you can check. But it's kind of nice if you're doing it right. Questions, comments about any of the stuff I've assigned? Or done on the board, I should say. Perfect. Let's get to the homework again. Here read those. That way you get some time to work. Assignment will be due on Thursday this week. You guys want me to leave that on the board?
Yeah.
I'm gonna leave that one on the board. Actually, I'll leave both. I'll just put it over here. Black. Okay, this assignment's due on Thursday. It's 10 problems. I went significantly less than what I gave you the last time. That was kind of overkill. If there's any of the problems that have powers, like powers of 2s, like that one has a power of 5, if there's any that have powers of 2s or more, try to do this rule. Try to do the triangle rule. Question? Yes. Okay. Here's your homework. It's page 53. Page 53. What do we got? 10, 11, 14, 18, 24, 29, 57, 68, 77, and number 85. It's due Thursday. And what is Thursday, the 13th? Yeah. September 11th it is. In 2001, how old were you guys?
We were like,
You're not born. How many?
I was
born.
I was born.
No.
I was 1.
Either way, nobody remembers.
So, alright. I just dated
I
myself.
remember like in grade
Wait,
my room doctor.
not born or one?
And that really good, I guess.
Because I wasn't even alive.
What?
Wasn't even alive.
Wasn't even alive. It feels so old. Because when
It's your mom's birthday.
the terrorist attacks hit,
I'm 2 days.
I was a freshman in college. It was my first semester. and I was
So you wish
I
Travis birthday yet?
was.
No.
I
met.
I'm going to before you do.
Number, yeah, I've been 2 months,
I don't have her number.
7 months of pregnancy.
I wasn't even thought of yet.
I'm actually texting
Wow, that's insane. I could go
So nice. She's funny too.
really old.
Are you? Yeah.
Yeah, they had it on TV, it was live, it was the craziest thing I've ever seen in my whole life. And I didn't even know it was happening until my roommate grabbed me out of the shower and drove me back to my room. And I drove on.
Yeah, he's aware.